In addition to the primitive data types that Java provides, we can use object reference variables to define and use data types that we design ourselves. In the case of primitive variables, we have our primitive identifier, which links directly to the primitive data value in the computer memory. Reference variables are different in that the identifier actually connects to an address, which points to an instance of an object. The first thing we need to look at is how to declare, create, and assign identifiers to objects. In this case, we're looking at the example of a dice object, and we'll use that example throughout this video. The first step is to declare a reference variable. In this case, the identifier is myDice, and the type of the variable is dice. Secondly, the dice object is created. And finally, the link is established between the object and the reference. It's important to understand how assignment statements work with reference variables. Let's look at this example. We have two different identifiers here, each addressing or referencing two different objects. Okay, looking at this assignment statement, if identifier 1 and identifier 2 were primitive variables, then obviously that statement would result in two different variables of equal value. Reference identifiers work differently though. What happens with reference identifiers is that the object addresses become equal. What that means in practice, of course, is that both reference identifiers are now pointing at the same instance of the object, and the second instance of the object is lost. It's still sitting in memory, but we can no longer access it. Fortunately, Java has garbage collection processes which clean up that memory for us. Now let's turn our attention to writing the dice class definition for our dice objects. Here you can see that I've got two instance variables. There is int faces, which is the number of faces on the dice, usually 6. And we also have an integer variable called face value, which is the value on the face after the dice has been thrown. We also have a method called roll dice, which will be how we will roll the dice to get our face value. And here we have the Java code for our dice class. There are the integers faces, which is equal to 6, and face value. And then we have our method roll dice, which rolls the dice. It basically generates a random number between 1 and 6. Here we have the program which actually uses our dice objects. So it's the usual sort of import statements at the beginning, and then we have our public class useDice extends applet as usual. And then we have dice myDice equals new dice, which declares and instantiates our dice object. Then we move into our paint method, and the paint method runs the roll dice method. So that rolls the dice, and then we have a drawstring to display the result of that dice roll. Now there is a problem with what we've done so far, and that is that the data items in the dice objects are exposed. What I mean by that is that a programmer could use a command like the one on the screen to change the value of face value without using the roll dice method, and we don't generally want that to happen. We'd like to be able to protect the data in our objects, and by doing that we encapsulate our object and hide the inner workings of it from the rest of the program. You can see in red the changes that needed to be made to the class dice in order to encapsulate the dice objects. First of all, the variables are made private to limit their scope. Roll dice is changed from void to int so that it returns an integer value, and then we put in the return face value command so that that value gets returned to the program. And this is how we use our new encapsulated dice objects. You can see there that I have instantiated an integer variable called result, and the command you can see on the screen in red uses the roll dice method in my dice object to generate a result and then pass that back to the result variable, and I can then display it on the screen as usual. It's good practice to always use encapsulation in this way to protect our objects. So that's an overview of object reference variables.